Aloha, Richard Halverson here. This is ICS211, and this is the first live recording I've made for you folks in class can show up, and no one's here today, which is pretty typical. Often when people do come, it's because they have a question, and so we can always answer those questions at the beginning before I turn on the video, and then you can leave if you want to, but of course you're still responsible for watching the video later. All right, so I'm going to share my screen. Today I'm going to cover collections, chapter 14, I think. So let me share my screen. And so here we are. Let's see, I'm going to look at the syllabus, and we have, so far where I am is, if you look at the playlist, you can kind of see what's done as of today, July 12th. These are all the beginning videos up to actually you're kind of responsible for all the videos, but they're not all that long. Some of them are short. And this is the introduction, talks about the syllabus and so on. And anyway, I've separated out the videos that are going to help you do the labs. This labs 4-credit class, there's labs, 6 labs you have to do that's sort of beyond what the normal 3-credit is. And in those labs, the idea is that you learn an integrated development environment. We're using Eclipse, and so you're gonna create projects and execute programs and hand in projects and so on. And so that's what the labs are. I've separated those out to make it easier for you. Now these labs, especially those labs at the bottom there, you may not, in fact, it's better if you can do the lab without watching the video. And what you can do is you watch the video at the end to see, to summarize what exactly it is you're supposed to hand in. But the labs are kind of long and tedious, but I actually go through almost everything, except for maybe at the end, I'll say, okay, you got to fill in this code. But that's for people that are stuck. But I don't really spend a lot of production time on them because, I'm just doing them. I've done all these problems because I created them, but I haven't done them for a while. So anyway, that's what those are. So today we have gone up to chapter, I've covered all through chapter 7. So in theory, today's the 5th week, which starts this coming Friday. So we're sort of in sync now, and I'm going to try to keep up as best I can. Let's go to collections. So let's go to the textbook. By the way, I just want to make one note about the grade book. So I have posted grades for last week, and some of you freaked out because if you had scores, so you should have handed in theory, you should have handed in, chapters 1 through 5. Chapters 1 and chapter 5, chapter 1 and chapter 5. So if you didn't do them, I put zeros there for you. But when you do them, then the zeros will be filled in with what your score is. So all that does is to give you the hint that in theory you're behind as far as the pacing goes of the class. You can always do them. You can wait till the very end and do them all at once if you want to. That's not recommended, but there's been students that have done that, and they probably stayed up late and stuff. But anyway, so try to keep up with these lab assignments here. It's not the same as the lab. There's these things in the textbook called labs, which you know by now. These are graded manually, so these are a little bit different. It's pretty important that you hand in these assignments as soon as you get them done. And if it goes into the end of the week, if we don't have time to grade them, if you hand it in so late we don't have time to grade them, you may end up getting an incomplete with your grade coming later. So it's I don't want to discount for I don't want to take off points for handing stuff in late because we're all busy. This isn't high school, but you gotta, there's you know, there could be some consequences just because the stuff's hand graded. The stuff up here is all auto graded. So anyway, so let me go into the collections. So we are here, and so I'm gonna go see how far I can get. Let's see, there are. Well, this is the reduced version. This isn't the version I use. Okay, so to start with, we know about for loops, and we know about array lists, and we know about iterating through an array list using a for loop with the index, and that is a very efficient way to iterate through an array list, but it's not so efficient iterating through other kinds of collections, these ordered collections. And so this shows an example of there's what we call an enhanced loop, and these sort of for loops have different names in different programming languages, but every programming language has something like this, where you have, in this case, you have an array list here, and this for loop is going to loop through this array list one by one, and each element is you can refer to it as this player name, and so it loops through all of the players in team roster, one player name at a time. So this shows that. Click through these participation activities, and you get points for them. Okay, you know, you can still get an A if you don't do any. See, can you? No, I guess you can't really get an A if you don't do any participation activities. But they're easy free points, and it's going to either reinforce something that you already know, or you're going to learn something. And lots of times it's the latter, and it's answering these questions that makes it stick better in your head. Okay, so here's a regular for loop where we're looping through the team roster. This is how you do it without the enhanced for loop, and this is how you do it with the enhanced for loop. Okay, so go through those. Okay, here's a challenge activity. I like to get you started on these challenge activities. And so let's programs output. We are initializing an array list, adding 2 countries to the array list, printing out the word country, and then looping through those 2, looping through the array list and printing it out with the print line. Okay, that's what it is. Can I click on this? I'm gonna click on, it's a different problem. Let's do this one. You can do the first one. Let's do the second one here. They get a little bit harder. So we have an array list of car items, and we're gonna keep. Not sure what this. Okay. I see. Start with 0. We're going to sum up the car items. So first we're going to put in a 7, and then we're going to put in a 2 cart names, and then we're going to put in a 9, and then we're going to loop through these items 7, 2, and 9. That would be the order, and each time we're going to add it to cart total, and so then at the end it's going to print out the sum of these. So 7 and 2 is 9 plus 9 is 18. So I think it's got a print line there. There's a total in front of it. Total :space 18. Enter. And check. Yes. Okay, you can do 1 and 3. Let's go on to linked lists. Okay, so that example was using an array list, the simplest kind of collection. The next one we're going to learn here is the linked list. And a linked list is just very much like an array list, except for internally it's implemented differently. Okay, and because of the way it's implemented, there are advantages and there's disadvantages. So your job is to know what this collection is going to be used for, and picking the right collection abstract data type for your needs. And what we're learning is the Java implementation of these abstract data types. Okay, so here's how you create an instance of a linked list. You can put any type in there. It's got to be it's got to be a class, can't be a primitive type. So, you know, so it can be some class name usually, or one of the wrappers like integer with a capital I, or string with a capital S, and so on. Okay, so here, and you have to put this at the top. So here, okay, so make sure you go through this example. We instantiate or create an instance of the list, and then we add 3 things to it, and then this is a special kind of add where we can add at the first element, put green in there and shift all the rest of them down. So this list would have Gaimal, Penrose, and Hawking, and then when this comes along, it's going to push Penrose and Hawking down by 1, and so it'd be Gaimal, Green, Penrose, and Hawking. So click through that to see that, answer these questions. Let's see, do we have a set will change the one at 2 at the second index, change that to Sagan. Okay, 0, 1, 2, so change it to Sagan. This removes, and this is the index, and these are the common linked list methods, same as in an array list, but the implementation down below is different. So these are, you know, the get, set, and remove methods of linked lists, just like array list. Iterating through the list, you can iterate this way, just like you can an array list. But the problem is that the linked list does not keep track of the index. Okay, it doesn't keep track of the way it knows that you want the 5th index is it starts at the first one and counts to 5. Okay, that's not how an array list works. An array list is, you want the 5th index, you just go right to the 5th index. So anyway, so this is not efficient at all, because when I is equal to 2, it gets to 2 by starting at 1 again, and when it's doing 3, it starts at, you know, 0, 0, 1, 2, 3. When 4 is 0, 1, 2, 3, 4. So it's an O(n) squared thing instead of O(n). Okay, anyway, but there is this thing called the list iterator, and you can you know, if you have a linked list and then you declare a list iterator as the list iterator of your authors list, then you can use this list iterator object, which has these methods which will sort of, you know, keep track of where you are. It keeps track of an index, and you just ask the list iterator for the next one, or the previous one, or the one, or I want to change the one you just gave me. It's got those kinds of methods, and so this has to be created along with, it's this thing. So first you have to create the linked list, and then you can create an iterator, and then you can assign to this list iterator the iterator for authors list. So anyway, so go through this, make sure you understand how this list iterator works. You think of it as being just before the next element, and so when you ask for the next element, you can say, does it have a next element? And if it does, get the next element. And that's, so you kind of think of it as being in the middle of elements. So anyway, these are the common list iterator methods. It's got everything you need, and make sure you understand those, and this tests your understanding of that. Oh, look, here we have a challenge activity. What time is it? Okay, so here we're gonna we create a linked list called letters. Oh, here we're going to iterate through just one at a time. See, so when you say get I, then it's gonna you know, get the 5th one. It's gonna, if I is 5, it's gonna start at 1, 2, 3, 4, 5. So it's each time you do something like this, as this changes, it's got to start from the beginning to find the right one. That's what this one does. Let's do the second one, because I think the second one we're actually using a list iterator. Yeah, this uses a list iterator. So this does the same thing as the first one does, but this is the preferred method when you're using a linked list, is to use a list iterator. So what does this do? We create a numbers, and we create an iterator for it called that, and we set that equal to that. In the meantime, we throw in a couple numbers, and then we set this list iterator, and then this grabs the next one, and then this inserts one. I might not get this one right. Let's see. Next actually does increment the returns the next element and moves the list iterator after the element. Okay, so all right, let's see if I can get this one. So adds 18, adds 17, and then it creates this list iterator, goes past 18, and now it's pointing to 17. And I think adds it before the next one, adds a new element between the next and the previous. Okay, so it's going to be before the next one elements, and moves the list iterator after the new element. Okay, great. So we're going to do at 17, we're going to add this 19. So that's going to push the 17 down one. And so now we have 18, 19, 17. So that's how we list this out. We go for the iterators. This initializes the iterator back at just before the first one again, just before index 0. And then this is, and while it has a next one, it's going to grab it and output it. So it's just going to grab out what the linked list is in order. And I'm thinking it's 18, and then we inserted that 19 in there, and then the 17 got pushed down. And it's a print line, so it's going to have a return. And let's see if this is right. All right, very good. So you do 1 and 3. All right, this linked list and array list are abstract data types implementing the list interface. Although both linked list and array list implement a list, a programmer should select the implementation that is appropriate for the intended task. A linked list typically provides faster insertion and removal, and the list ends and at the insertion. Faster insertion and removal at the list ends and in the middle if you have a list iterator, whereas array list offers proportional access, positional access with indexes. C2, and what they're talking about is if you're going to insert an element in the middle of an array list, it's got to shift all of them down. If your array list has 1 million elements, you're going to stick one in, or even if you're going to put one in the top, it's going to have to shift the whole array down one. Whereas with the linked list, you can just you unlink and you put that one in there and link it up, and it doesn't take any more time than just it's an O of 1 operation instead of O of n. Okay, I've covered sections 14.1 and 14.2, and I think I will leave the lab for the next video. Thanks for watching.